All right, so this one says we want to convert the logarithm equation to an exponential form. All right, so log equations are going to come in the form of a log with a base, and they're taking the log of something and setting it equal to something else. Like that's just the general form of a log equation. We can rewrite a log equation by taking the base, here the b, and making it into a base on its own side of the equation where we raise it to a power. But the power that you raise it to has to be what's on the other side of the equation. Okay, and then the y here, whatever you're taking the log of, that goes on the opposite side. Okay, so this is called logarithmic form, and this would be exponential form. Okay, let's try to apply that to this problem. So we have a base of x. That needs to go on one side of the equation, and we have to raise it to the power of what's on the opposite side. So it becomes x to the fifth. Then we take that 243 and we put it here. That's all you have to do. You don't have to solve this equation. It just says put it in exponential form, so that's done. If we did want to solve it, though, just out of curiosity, in case it asks that, just raise the left side to a power of 1/5 in order to cancel the power of 5. And then we would get that x is 243 to the 1/5. I'll just do that on calculator. It was 3. X is 3. Okay, let's try this one. Convert the logarithmic equation to exponential form. So here, a base isn't given. But if it's not given, then we have to assume that the base is 10 by default. So we can rewrite this then as log base 10 of x equals 5. So let the base become the left side of the equation here, raise it to the power of what's on the opposite side, and then set that equal to x. That's the answer because it just wants the equation in exponential form. But it looks like if we did solve it, we would get 100,000 is x. Okay. Here we're doing the reverse. It says convert the exponential equation to logarithmic form. So I said before that if we had a log of a base and you're taking that log of one thing, setting it equal to another thing, that this could be rewritten as b to the x equals y. So the b and the x go together on the left, and the y goes on the opposite side. So what we have here is we have something which is similar to that, but it's in exponential form, and we just need to take it back to logarithmic form now. All right, so this 1/2 is your base b of the log. And so we just got to write this now as log base b, which is 1/2, of something equals something. And we just have to put the right things into the right place. But yeah, when you raise the base to an exponent, that exponent came from the opposite side of the equation. And so see that x there needs to actually go over here. And the 32 is the thing that we're going to take the log of. Now, how else could you arrive at that same result, just out of curiosity? Is there another way to get that answer? Let's see. Start with 1/2 to the x and take a log of both sides. This would allow your exponent to come down in front, because we can use the rule of log of something to a power, the power comes down in front. And you would get x log 1/2 equals log 32. And so you could solve it then by doing a division. But you can see that this is equivalent to that according to the change of base formula. That's correct, yeah. All right, this one says convert the exponential equation to logarithmic form. So let the base of the log be the 4. Put the 1/64 in the parentheses and put a -3 on the other side. You can always check your work by trying to reverse the process. Like, how do you go back to exponential form? 4 to the -3 equals 1/64. Like, it checks if I try to reverse the process.